All right. So we're going to consider that as displacement. We're going to have x equals x naught sine omega t. How do I get velocity from displacement? You're going to have to think way back to kinematics. Yeah, I did just say the K word. Kinematics. Okay, I could use a Suvot equation. How else can I get velocity from displacement?
You have a graph.
If I have a graph,
You look at the slope of a certain point.
does everybody remember that? If you don't remember that, you better remember that now.
I do now.
Velocity is the slope of the displacement graph. Okay? Is that fitting? No, that totally didn't fit. Okay. Velocity equals slope of displacement. Okay. Now, if we were 12 months from now, we would do this using calculus. Unfortunately, I'm under the assumption that most of us here don't know calculus. Anybody know how to take the derivative of a trig function?
Kind of. Oh no, not a trig. Not a trig.
Yeah, that's true. Okay, so what we're going to do instead, and this is why I wanted the SLs here, part of this. Part of it is the discussion that we just had talking about the relationships between the two. But what I want us to do is I want us to look at a sine graph.
Yeah, it's close. It should be.
Okay. So sine graph, right? Max of 1, minimum of -1. Values are pi over 2, pi, 3 pi over 2, and 2 pi. Now, I recognize that the period is going to be different, right? So it's not really going to match up with pi over 2 pi, 3 over pi over 2. But the important thing is we want to figure out what would the slope of this graph be. Now, that's going to be difficult because there's a whole lot of slope going on there,
Yeah.
right? Now let's see what we can figure out. So this is my sine of x graph. Let's look at the slope. So slope of sine of x. All right? What can you tell me about the slope? What do you know for absolute certain? Where can you tell me what the slope is?
Pi over 2, it's 0.
Here, can you tell me what the slope is?
0.
It's flat, right? We've talked about that with parabolas and all that other fun stuff. So the slope is definitely 0 there at pi over 2. Okay, so 0. All right, where else can you tell me?
3 pi over 2, it's also 0.
You can tell me about 3 pi over 2, right? Because that's also flat. Okay? So here at 3 pi over 2, I've got a slope of 0. So I'm still graphing a graph of the slope of this curve because the slope's always changing, so I can't really just say slope equals 7. I got to have something that lets me show all the slopes for that whole thing. All right? What can you tell me about the slope here? It's positive, right? Is everybody okay with the fact that it's always positive between there and there? Yep. So I know that from 0 to pi over 2, I got to have a positive slope. Okay? What about after pi over 2?
It's still positive.
Negative, 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 negative. Still negative slope, right? My slope's here. It's increasing, but it's still a negative slope. Can you see that? I draw my tangent line, it's still negative. It's still going down until where?
3 pi over 2.
Until 3 pi over 2. So my slope has to be negative, so I got to have negative values between these two. And then after 3 pi over 2, you can see the slope is positive again. Okay, so my graph has to be positive, and then negative, and then positive. And now I'm going to tell you something that you're just going to have to accept for now. The maximum slope there, it's negative though.
Oh, it's negative?
It's going down.
Oh, yeah.
But Sajin is right, is -1. Okay, so if I put that in, so if I go down to -1, and I put that at pi, so that's the maximum, well, the steepest slope. What do you think the slope is there? Knowing that sine curves are symmetrical, and knowing that it does the same thing over again, if it's -1 here, what do you think the slope is there? Positive 1. And therefore, what's the slope here?
Positive 1 again.
Also positive. What does this look like? I got a point up here, I got a point there, I got a point down there, point there, point there. What does this look like? Can you connect the dots?
Connect the dots.
Is the slope constant?
No.
Do you think it's changing at a constant rate?
Yes.
We don't know. That's okay. We don't have enough math to figure that out yet. The answer is no, it's not changing at a constant rate because that would make it a straight line.
Oh yeah.
Okay. What we can see though is that the slope of the sine graph is.
I thought you just said going down was a negative.
Hmm?
I thought you said going down was a negative.
That means that the slope has to have negative values.
Oh.
And so it has negative values here. Yes, that is a hard thing to do, to say this is a negative slope, which means negative values here. Same thing here, positive slope, so positive values. You'll do more of that in math. Don't worry, it's coming next year. Oh, you won't have to worry about it then. All right, so the thing that I wanted us to get from that is that recognizing then that we now have an equation for velocity, which I actually put on here, so I'm not going to write it. Now, one thing that you don't know about finding slopes is the whole derivative thing. It's going to require that we have this extra omega on the outside. Okay, so don't worry about the mathematics where that comes from. The thing that I wanted you to see is that the slope of the sine curve is a cosine curve. Recognize that it's the same period, right? These two have identical periods. It's just the new trig function. That's what I wanted to see. So same period, same horizontal stretch, right? And then they will have the extra omega on the outside. So we talked about the maximum displacement. What would the maximum velocity be?
At equilibrium.
X not angular. Yeah, X not the thing.
What is the biggest thing that cosine of omega t can be?
1.
Biggest thing can be is 1. So if that's 1, that means the largest velocity is
X not omega.
x naught times omega. So x naught omega is the maximum velocity. So that means the maximum velocity is occurring at the maximum displacement. That doesn't work.
Uh-oh. Oh no. Did we do something wrong? What have you done, IB?
Is it time for that 3-minute break now? I did.
We'll come back to that.
Wait,
Let's talk about acceleration. We'll come back to what?
on the graph though, when the displacement is 0, that's when the cosine graph has its maximum. So when displacement is 0, then the maximum velocity should be
0.
The velocity is supposed to be at its max.
Yeah. We can see that from the graph over there.
That's so snazzy.
Yeah.
So it's true, but it's not supposed to have its maximum velocity. Oh, yes, of course. Those aren't happening at the same time.
Oh, yeah.
those aren't happening because you need different t's here in order to get this to be 1, in order to get that to be 1. Thank you, that pointed me in the right direction. Yes, beautiful. So the maximum velocity depends on what the maximum displacement is, but it's not occurring when the maximum displacement is happening. Which makes sense, right? If you take a spring and you stretch it further, then it's going to get going faster before it gets to the middle. We know the maximum speed happens at equilibrium, right? And so it'll be going faster, so it depends on that, but it's not at the same time. Okay? Okay. Now, we can do a very similar relationship in order to get acceleration. How do we get acceleration? From velocity. Velocity over time,
The slope
which
of
if I have a graph,
Of the
the
velocity.
slope of the velocity graph.
Velocity time.
is the slope of the velocity time graph. Okay? So we could do a similar process in order to figure that out. Alright? Now what we get the extra W again. The cosine turns back into a sine, which kind of makes sense. I'm not going to do that math part of it. I wanted you to see it once. You'll get to see it again when you do math next year. So we got the idea, right, that the sine is going to give me cosine as a slope. It should kind of make sense then that the cosine is going to give me sine as a slope. What about this negative, though? Where's that negative coming from?
Oh, wait, simple harmonic motion.
Acceleration always moves towards the.
Okay, so one important thing is that we know by definition that the acceleration is opposite the direction of your displacement, right? If your displacement is over this direction to the left, what direction is the acceleration?
To the right.
To the right, it's towards the middle, right? So we know physically it makes sense. If you go through the mathematics, we recognize that we have a slope of 0 here, but then what happens to my slope?
Oh, it goes backward.
It's negative, isn't it? And so if I were to do this graph, it wouldn't look like that. It would start at 0 and it would go negative first. And it would do that, which is why we get the negative sine graph. Alright, so we're making links. Part of the reason of this is making those links between the physics and the math. Okay? Maximum acceleration. Maximum acceleration? What would it be, Oliver?
Oh,
Maximum acceleration.
Like minus x beginning probably omega squared as sine has to be as.
That's right. So negative x omega squared is my max acceleration. That's right. Okay? Now, the beauty of this is it puts together all of our information about simple harmonic motion, right? It takes that idea of the force or acceleration and displacement being proportional. It also takes that idea of the force and the displacement being in opposite directions, right? All of that is contained in here, okay? We're going to talk more about that later. But for now, here's what I would like for you to do. I need everybody to stand up.
Yes, stand.
I'm so scared you're gonna test faster. Test is faster.
I think you would have like 0.4.
Yeah, but he.
Like honestly.
But he said most of us did horribly.
Most of us.
On what?
The multiple choice.
When's the recess? Wait, did anybody get 0 right? Please say no.
You know, it's really hard to get 0 right.
He said only
No, it's possible.
Wait.
Oh my gosh!
Oliver.
Wait,
only,
No.
only one person.
We don't know. We don't
They don't use too much.
Excuse me.
Probability is not.
Oh, okay. Oh, right.
See, I think the probability gets really, really skewed in this class.
Yeah. One who did really good.
Probabilities, like, probability shouldn't even exist in this classroom.
Did
Look at this scores.
Well, when they're trying to create choices to distract you, or they're trying to phrase things in ways that will catch your understanding, then probability doesn't matter. Because you're not guessing. You're trying to use your understanding, and if your your understanding is limited, then it tends to go towards the wrong answers.
Yeah.
So it's a higher probability of getting a wrong answer.
Ooh.
So it's not, the probability is not straight up 25% free. It's definitely.
So like, because I'm gonna be so mad if I didn't do well on this test because I did okay on quiz.
I didn't do okay.
Is this test dance?
Oh, yay!
Are you, oh.
We're gonna just dance.
Is this it? I have this at my house all over. We can do this in karaoke.
Okay, you're gonna need some space.
Are you joking?
I'm sure none of us can.
I did 4 test dance.